So I wanted to give you a quick video about the typical problems in Module 3, Lesson 2, 3, and 4. They're all kind of the same. This one is in Lesson 4, number 12. And on all of these that deal with the normal distribution, you're going to use StatCrunch to find your answers. So let's just, we can read this one. The red blood count cells for a population of adult males can be approximated by a normal distribution with a mean of 5.7 million and a standard deviation of 0.3 million. What is the minimum red blood cell count that can be in the top 30% of counts? So pretty much every problem in Module 3, Lesson 2 through 4, you're going to use StatCrunch. Get this in the screen here. You'll go stat, calculator, normal. Right, so stat, calculator, normal. And you'll get this normal distribution. And look, there's 1, 2, 3, 4, 5 places where you can enter data. And the problem's always going to give you 4 of them. And the last one is going to be your answer. So the mean and standard deviation are always going to be given. If it's Z, if they say it's standard, normal, and Z, it's going to be 0 and 1. Otherwise, the problem will give you the correct mean and standard deviation. And then this is the limiting point here, right? So in this case, it's the point that delineates the shaded region. And this is the area of the shaded region, all right? So this box here, it can mean 3 different things. It's either the area of the red region here, or it's the percentage of the data that's in the red region, or it's the probability that if you selected a data point, it would be in the shaded region here. So you have to find out, what does the problem say? Is it a percentage? Is it an area? Or is it a probability? And if it gives you one of those, it's going to be data that you should put in this box here. And then your answer is going to be over here, and you'll have to pick the right inequality over here. So anyway, let's do this one. So it says, what is the minimum red blood cell count that can be in the top 30% of counts? All right, so in this one, it's not giving you a probability, it gives you a percentage. So this is the number that goes in that last box. All right, so we're going to put 0.3 in here. I think it said 0.3. 0.3, and then the mean is 5.7 and the standard deviation of 0.3. Standard deviation is 0.3. And then the last thing it says, the minimum that can be in the top 30%. That means the red region is going to be on the right side. So I pick a, greater than or equal to, all right? So here's the numbers I put in this last box, this 5.8. That's going to be my answer. So, oops. 5.7 and 0.3. And 30% of counts. Point 3, 5.85. All right, so there it is, 5.86. All right, 5.86 when you round it. Okay, the next question here is, what is the maximum red blood count that can be in the bottom 10%? Again, this is a percentage. It's going to be in that last box of 0.1 and less than, right? 5.32. All right, 5.32 is your answer. So, I think this is a pretty easy part of the course. If you know how to use these 5 boxes here, mean and standard deviation go here. This is the boundary, so that's part of it. Figure out where the boundary is going to go. This one is going to be one of 3 things. The question is going to ask for the area. It's going to ask for the percentage, which it does here. Or it's going to ask for the probability, and that goes in this box here. So I hope that helps you out a little bit. Let me know if you have trouble. Send me a note, and I'll be happy to help you out.